folks. I hope you enjoyed Amber's introduction into Arize. So to get us started, my name is Datno. I'm a ML Solutions Architect here at Arize, and today we'll be taking a deeper look at some more advanced Arize workflows. So a little introduction about myself. I was a data scientist for a long time, built a lot of ML infrastructure, worked with many of our clients that we have today, helping to productionize, architecturally, how do we fit Arize into their stack. So today, we're going to go over some kind of advanced user workflows, what they look like, and really why. And so this workshop is best for users who are already familiar with Arize and looking to uplevel, their ML observability capabilities. But even if you're not familiar with Arize already, I'll try to give context to what I'm doing in the presentation so you can follow along. But if we have any, architects in the room, feel free to ask questions as we go along. I like to make this super interactive. So for our agenda today, we're going to do a few things. But today, we'll first go through, what it's like to set up a pipeline into Arize, whether it's like data. We'll go specifically through a data connector, but I'll talk a little bit about our SDKs and how you kind of integrate Arize from an ingestion perspective with your architecture. Next, we'll take a look at those embeddings and that embeddings data, and we'll go through kind of embeddings drift. So if you've been attending the generative stage, you'll understand that why embeddings are so important. I'll do a quick review on that as well. And then we'll go through a couple unstructured workflows to help us understand what's happening with our data set. We'll be using the computer vision human interaction data set. We'll kind of look at best practices and how you can really think about the space. And this obviously applies to generative models as well, the kind of hot topic. Thirdly, we'll create a business metric. So as Amber suggested before, let's say you don't want to use a statistical metric and you want to use something more business oriented. Generally, in today's kind of economic climate, it's always a really good idea as a data scientist, as an ML practitioner, to associate your ML model with some sort of P&L, or how does it bring value to the business? So we'll go through that. And then lastly, we'll talk about some programmatic access with Arize. So, how do I programmatically access items in Arize? How do I programmatically perform actions inside of Arize? So we'll create a custom business metric with doing that. And then we'll also set up a monitor. And the idea here is that we can set up patterns so that, let's say you have a self-serve platform and for your organization. The idea is, how do we automate these things kind of out? So let's get started. I don't have many slides. I think we're just going to go straight into it. So first thing we're going to do is set up a data pipeline using Arize. So if you've probably seen it before in Xander's workshop, but there's a computer vision human actions kind of data set that we like to use. It's in the demo models as well, so feel free to play with it. But essentially what I did here is, so downloaded some dependencies. I got the data from our, Google bucket for Arize. We kind of have, hey, where's the image and what's our prediction on that image? And all I really did here was package up the data to kind of mimic kind of the data that might be written to, an object store. So for kind of context, there's a few ways that we can integrate Arize with our current stack. And some of those ways include, if you've gone through any of our tutorials, you'll probably see, our SDK in there. And that looks like something like this. It's a pip install Arize. Really kind of great way to send data in kind of your first go around. The real architectural pattern here that I like to think about is, if you're not persisting inferences in the cloud, cloud storage, like some sort of file store or blob store, or some sort of data warehouse or data lake, then it's a really good idea to use the SDK to kind of push inference logs or inference data to Arize. So just realize that that's kind of out here, but for the purposes of today, we're really going to focus on So I have set up an S3 bucket inside my own personal account, and we're gonna see if we can connect to that and push data into Arize. Let's go ahead and do that. So for context, I kind of packaged up the data. It kind of looks like this. You can say, hey, where the image resides. Here's that embedding or image vector. And we have predictions, labels, and some other data. But as you can see, all I really did here was I've just packaged up the pandas data frame as a Parquet. You can imagine this as, in your production system, you have Parquet files being written or persisted to a specific bucket or prefix. So really quickly here, I'm going to log into my AWS account. So I'm going to go to my console. And then upon setup, I'll quickly walk through what the setup looks like, but I'm just going to go to my S3 bucket. And so here we can see that I have my dat Arize bucket, and I have a prefix called Arize. And inside of this prefix, I have my Parquet file that I just generated. So what are the steps to getting data into Arize from my cloud storage bucket? We can walk through let's kind of walk through the wizard together. So it is as simple as a wizard. But the idea here is, what's happening underneath the hood here. So Arize is essentially, when we think about how we're kind of pushing data with the SDK, we can think about the data connectors as kind of a pool. So as an example, oops, I got logged out here. As an example, I'm going to log in right here. So as an example, we can walk through this wizard right here. So upload an S3 kind of from an S3 bucket. So the first thing I want to do is specify my file path, right? And so I'm going to go ahead and grab that from AWS. Let's do this. And then let's copy the S3 URI. And then I'm going to come back here. And so I don't want the Parquet file in there, but what I'm doing is specifying everything kind of before that. So really, the wizard's really good at kind of knowing what you're looking at. So the bucket is dat Arize bucket. And of course, that prefix is Arize. Now, when we want to set up this connection, there's a couple of permission configurations we need to set. They're not particularly hard, but the first one is really this Arize ingestion key. So what is this and why is this important? So this key helps us understand on the Arize side that you own the bucket. So if I kind of go back to this bucket and I go over to properties, I can see that I have my Arize ingestion key and then that value, right? So this helps ensure that you are the owner of said bucket and that, there's a two-way street here saying, hey, you own the bucket. And then also this last part, the AWS policy says, hey, Arize can, read this bucket. So if you look at the kind of policy here, we can see that we're giving essentially a principal to this resource, Amazon resource, and says, hey, we can get the bucket, we can get the objects, and we can list what's inside that bucket. And so down here, you'll notice you'll want to definitely specify which bucket that you're allowing this principal, essentially Arize, to kind of have access to. So I've done that. And then if I go, I'll copy this policy and then I'll come back into the bucket. And then under permissions, you should see something that says bucket policy. And so you can kind of paste that policy there. One thing to note too, this example is for a public bucket. There is another workflow for private buckets, which we won't get into today, but realize that that's something that you could also set up. So if you wanted, a private bucket with your images in there, the really cool part about Arize is the images would only render for folks who have access to that bucket. So that's really cool. So on to the next kind of step. I can click next down here. So now I want to start setting up some basics. So what is my model name here? So if you are an architect or you're setting this up for kind of enterprise, if you're using something like MLflow, for example, you can always grab these parameters from there. And the whole point here is to have parity between both systems. Also, another thing is you can set up these jobs programmatically. So right now we're going through the wizard and the UI, but just realize you can automate a lot of those variables from, let's say, using MLflow to oh, thanks, Sander. I can zoom in. So the idea here is you can actually programmatically set those, ML flow variables like model name, model version, things like that. But for here, we're just going to do, DATS test bucket or test model. Let's do test CV model. And this is going to be a classification example. I'm going to leave this as production. I'm going to leave the version as none, but we can set it if we wanted it to. But of course, you could get this from, your serving or your model store system as well. I'm going to click next, and then here we're going to go into schema mapping. So essentially, when Arize pulls in the Parquet file, it wants to understand, hey, which items, what columns are what. So for prediction ID, I know this particular schema that I set up. So prediction ID is prediction ID. Prediction label is going to be pred label. And then the actual label is just going to be regular label. And I don't have the rest, and that's okay. So I'm just going to kind of click forward here. And then here we're into the schema mapping. So here, if I have, tabular data associated with my unstructured data, I can add that here. But the things that I'm going to fill out are my timestamp. So when did, my model make this particular prediction? It's going to be prediction underscore TS. And so here, we're going to do something kind of special. Since we do have embeddings here, what I want to do is click add embeddings feature. And the embedding name I can just make up is like the human image. This is kind of the name of the, embeddings feature that I'm looking at. And then what's the column for the vector? So this is going to be pretty straightforward. It's going to be image underscore vector because I know my Parquet file. Lastly, when you see raw data or link to data, for computer vision, you can always attach some sort of kind of raw data here, textual. We tend to think of this as like maybe NLP. If you're doing reviews or something, you can always put the actual raw review here or something. Here I only have link to data, which is essentially what image does this vector belong to. And for me, this is going to be URL. And the really cool part about the wizard too is it's got very good schema validation. So if I get something wrong, for instance, I can click validate, and then Arize will let me know if I got things well or not well. So as an example, if I put, if I mess this up and I click validate, it will tell me that, hey, you've defined something that doesn't exist. So just understand that Arize will help guardrail you as you kind of move through the wizard. So as you can see, I set this up and I'm going to click next, and then I'm going to finalize this out. So as this, you'll see this file import job kind of working in the background really quickly. I'll refresh this. And so you can see that, that the import job that I should have set up should be in here. Let's see what happened. So it'll pop up in here. Let's do really quickly. Let's do that again really quickly. Do this really quick. This, that's already set up. Let's go here, test, and prediction ID. This is what happens when you do things live. Prediction. Yep, and then we'll go here, go image. This one will be image vector. Then we'll validate again. Okay, so there we go. And I'm going to click next and then start job. That's what it was. Okay, I'm going to click start job and then finish. So you will notice that this data will be, it'll kind of import into Arize, but I do have the demo data set here. So it essentially should be the same thing. So now we're kind of on to part two, which is really going through some embeddings workflows. So let's go through the embeddings workflow. I have kind of the data already preloaded inside of here. And the idea here is, what are embeddings and why are they important? So TLDR, embeddings are foundational to pretty much all unstructured models. You can think of them as representations of the unstructured medium. If you watch Xander's kind of Phoenix presentation, he kind of went through this. But the idea is we can do, really cool things with these, like understand when we're having drift issues or data quality issues. We can find those issues. So let's go ahead and get a quick, example of what that workflow looks like. So here, what we're looking at is the embeddings drift between, what did I train my model on versus what's happening in production. If you look at this kind of yellow line here, what this represents is what's the distance between these two, centroids of these two sets of data. If you see this kind of big spike here, what the spike represents is we actually tried to introduce issues into this model. We wanted to see if Arize could catch it. So this visualization down here is a 3D representation of the embeddings. So the reason why this is important is because, when we're building intuition in the space, and human intuition is super important here, because when a human looks at just regular embeddings, a human may not know what that, many dimensional list of float values represents. But when we kind of look at this 3D, pictation here, we can get a good feeling that, these are my embeddings. These are kind of where they lie in the embedding space. So we use UMap to kind of project down into the 3D space. So very quickly here, remember how I said we introduced issues here? Let's see if we can find those issues. So the first workflow that a lot of people will use is this one. It's like, where's my data coming from? So as an example, blue here represents what's happening in my training data. Where did I train the model on or expose it? In the generative world, this could be, hey, what are the prompts that I'm usually getting? This could be, we could be comparing training versus production, or what happened last week versus this week. But here in this example, this is kind of my training data, and here in white represents my what's happening in production. And what you're looking for here visually is, where am I seeing areas of kind of white that don't have blue? Essentially, where's my model making predictions where it's kind of never been exposed to? So kind of manually, we can grab our lasso tool and see, like, there's a lot of kind of white points up here without a lot of blue. So a lot of, dense clusters of white. I can grab those points and kind of see what we did to kind of trick our own model here. So we did a few things here, like we did a black and white and kind of a blur. We did what's called here a salt and pepper, where you take random pixels and RGB them. And the whole point here is, like, great, I can understand when something goes wrong and when I'm seeing drift or something that's actually changing in the real world. But the really cool part is I don't even have to do this manually. As a quick example, if I look at, this left-hand pane right here, underneath the hood, Arize has a clustering algorithm to help the user understand. The platform will tell the user, hey, these things are kind of out of distribution, or they're things that we kind of don't expect. So if I click cluster 1, it'll actually kind of outright point to the problems here, or the issues. And so we can see that Arize does a really good job of picking out, where are we seeing issues and kind of why. So here at cluster 2, we can see we have some blurry images, but most of the problems all lie in kind of cluster 1. So that's a quick example of how Arize can help users really get a feel for what's happening in their data, how things are changing. The next thing I'll cover really quickly is really, we can also color by tabular data. So you'll come to know that, if I grab some points here, that if you look at some unstructured data, you may or may not have some tabular data associated with it. So for example, if you're, I don't know, in the computer vision world, you can say, hey, where was this image taken? Who was it taken by? What was the context of the image? In the generative world, this could be time of day, who generated it, maybe the subject, or any other kind of tabular data you want to associate. And the idea here is, for the first time, you'll actually be able to discern patterns between unstructured and structured data. So what I can do is I can take a look at the unstructured, nature of my data via embeddings, where are things kind of located in the embedding space, and actually color by the tabular space. So if I want to understand, am I seeing specific clusters in a certain area? Why is that, etc. So really cool workflow there that a lot of folks really use. And the last workflow I'll get into really is just, how do I know if things are going well or not well in the unstructured space? So here, what I'm doing is coloring by my prediction label, right? And then I'll also, let's suppose I do have my actuals in this use case. What's the difference between the two? Well, it's going to be something like correctness in an image classification problem. So what did I get, wrong versus what did I get kind of correct? And more importantly, you probably want to go a little deeper than that. Maybe you want to understand what type of right and what type of wrong. So if I color by this confusion matrix here, um, most people probably don't care too much on what their model got right. So I'm going to remove these true positives and true negatives. And what I'm left is with maybe, my false positives, false negatives. Maybe I'd want to optimize for one or the other, depending on the business use case. You may want to optimize for a specific one. What I can do is actually, select those points, and maybe there's a specific cluster or area I want to focus on. Uh, I can grab a specific cluster of false negatives and say, hey, what do these points share? In terms of image or even, tabular data. Is there a pattern I can discern here? And the reason for this is really, if you want to optimize for a specific area, it's really good to understand patterns at a human intuition level, so that then you can make those changes to your model kind of outright. Okay, so that's a really high level overview of embeddings. It goes like so much deeper, but we're just going to scratch the surface just because of time. So the last thing I wanted to cover, or the last two things I wanted to cover really was custom business metrics and why they're important, and lastly GraphQL. So these two will kind of go in tandem, but very quickly I'm going to switch over to a different model to kind of illustrate the point. So here we're going to take a look at a fraud demo use case, and then here what we're looking at is, we're classifying kind of fraud, not fraud, trying to get a good sense of if we're detecting fraud and kind of, are we detecting fraud and are we detecting it kind of well? So let me open up this. A little bit about GraphQL and why it's kind of important. So inside of Arize, you can actually, we have a kind of GraphQL interface that you can actually play with and use. The documentation is kind of built in. So if there's things I want to do, like query items or do what's called mutations or kind of actions or kind of patch or change things, you can. So just realize, though, that you don't have to use this GraphQL. It's just very useful to kind of use it in platform because the IDE is very useful at like kind of autocomplete. But just realize that you can use, you can kind of do the same thing with, for example, a Jupyter notebook. So I'm going to quickly go here and go to our GraphQL API. So there's plenty of examples inside of the docs. So let's say you want to create a performance monitor. There's a collab here. So if you wanted to ever instantiate this outside of Arize, you can always just pip install GQL. From GQL, import the client. You give your GraphQL key, and you can kind of do all the same things that I'm doing here. But the first thing I want you to note is when we're taking a look at a fraud use case, maybe the metric of choice we're looking at is our false negative rate. Let me configure the positive class really quickly. And so, what we're looking for is fraud. And so while this is a really good metric for, a good statistical metric kind of for a fraud model, it doesn't always tell the full picture of what's happening in the business. So as a quick example, you may be catching fraud for maybe super small transactions, but if you're missing fraud on super large transactions, what does that mean to the business? So as an example, maybe I don't want to use false negative rate and I want to use a custom metric. So let's build a custom metric to help us understand maybe a better way to gauge how well this model is doing. So maybe the custom metric I want to, create is, what's the total amount of fraud caught, for instance. As an example, I can say, total dollars in fraud caught. So what I can do here is I can actually define a custom metric using a SQL-like syntax. So imagine select star from. I have plenty of available functions, pretty complex functions and operators that I can select from. You can see some examples of, maybe I want to choose a percentage of this feature with an X value. So think, count of, some sort of filtered column. But for this purposes, we're going to just do kind of fraud caught. So I won't actually just code this from scratch because it's going to take too long, but I already have one kind of built out. And what this is saying is like, hey, select basically all the loan amounts that we've loaned out. And we're going to filter where our model guessed fraud and the actual was fraud, right? And so if I run this just to double check, this is going to, I'm going to save this metric, loan amount where, perfect. Let's save this metric, and then this will update. And if we kind of go back here, we can now see the metric that we're using. And then I want to actually look at the fraud caught that I just created. And so here what we can see is the total amount of fraud caught in dollars. This is great because now I can see at a slice level how much fraud are we catching for each merchant, et cetera, et cetera. It's a much better way to relate to the business, true value. Because imagine that case where we were just, catching fraud, but only for small transactions and missing the bigger ones. You can definitely see how that can affect the business pretty severely, even though your model looks good on paper. The last thing I'm going to do really quickly is show you that you can actually do this with GraphQL. So as an example, maybe I just created a total, fraud caught in dollars, but maybe I want to create a metric that actually catches what's the total fraud kind of missed, for example. And so here, what I'm going to do is I'm going to say total fraud missed. So here, what I'm going to do is I'm going to select the metric. And this is the SQL-like statement that I have. The model ID I can actually find. So I wanted to quickly show you this. The model ID can be found kind of right here, right behind models in the URL. I'm going to grab this base 64 encoded model ID here. So my model ID is this. And I'm going to say fraud missed. Let's see if this works. Let's go ahead and run it. And you can see that this ran. So let's kind of go back into the fraud model and see if we have a new custom metric that kind of popped up. Let's do this. So we should see, we should see total fraud missed right here. And we can see that this value is kind of what we expected. It's where we have, we guessed fraud, but the actual was not fraud. Actually, I think it's the reverse here. Oh no, it's actually where our prediction was not fraud and the actual was fraud. So that's a quick example of how to use GraphQL to create a custom metric. And I know we're kind of coming up on time here. And so the last thing I want to kind of show folks how to do is how do we set up a monitor with GraphQL? So if I kind of go back here, we can see that we don't have any monitor set up. So as Amber kind of showed, you can go into the UI and take a look at, you can take a look at, any monitors that have been set up through the UI, but we're going to do one through GraphQL. And so I have one kind of already set up. And a lot of these templates can be found in the docs. So, but I'm just going to quickly walk through it. So what this template kind of shows us is that, we have our kind of model ID here, which is the one we just grabbed from kind of here. And so we can name it whatever we want. It's going to be my, I guess, monitor. And the idea here is you can actually, if you're someone who's setting this up for another team, the idea here is you can automate this out. So if you know that there's a set of monitors you want to deploy for a certain set of teams, and you know that there's monitors that need to be set up, and you want to automate this out, you can kind of select everything from should this be an auto thresholding kind of monitor, how it should be set up. I even set up a little bit of a filter here to show users that you can be pretty customizable and you can add as many filters as you like. It's going to send an email to myself. So let's run this and see what kind of happens. So here we can see that this was set up. This was the threshold that was kind of set up by Arize. Let's go into monitors. I'll refresh this and see what kind of happened. Let's go here really quickly. And so we should see a monitor kind of pop up here if I set the right monitor ID, model ID. Let's see if I did. Just want to double check here. Okay, that's why. Okay, so now that that's run, let's go back here, go back to the overview and refresh, and then go back to monitors. So here you can see that monitor that I just created. If I take a look at that monitor, I can look inside of the UI. I apologize, my internet's a little crazy today. You'll be able to see that monitor kind of show up. And the idea here is, here's that monitor I just created with the auto threshold on. So as we can see, kind of our false negative rate kind of come up. For example, I would be alerted kind of in this spot as we kind of see it. But yeah, that was based off time. I know I gotta go, but that was a quick example of kind of some more advanced kind of user workflows that if you're an architect setting this up for another team, these are kind of a lot of tools that you can use to help automate observability in kind of your pipeline. So I'm going to pause here. Feel free to ask questions. I will be answering them kind of in the Zoom. I hope you found that useful. And so that's all I've got. But feel free to ask more questions. You can always email me at dat@arize.com. We can always have a conversation about these things. Thank you very much and have a great rest of your Observe.